Hi everyone. In this video, we are going to do decimals in this chapter, and this is the first video. We have 5 objectives and just some basics about decimal numbers. First, we want to learn how to convert a decimal number to a fraction or a mixed number. Then we want to know how to read a decimal number in a formal way. Then we want to graph decimal numbers on the number line. Then we learn how to compare two decimals to see which one is bigger, which one is smaller. And in the end, we look at how to round a decimal number to a specified place. Okay, let's do this one by one. So we are using decimal system. Decimal means 10. So every digit move represents 10 times difference in place value. So you see this is a decimal point. To the left, we have those whole number digits. And to the right, we have those decimal digits. The first decimal digit is in a place called a 10th place. Then 100th place, 10, 100, that's 10 times difference, right? Next one, another 10 times difference, we call it thousandth place, and so on. Now, let's look at some examples, how to convert a given decimal number to a fraction. So this one, you see, we have 2 decimal digits. Apparently, these 2 decimal digits here, you see the last digit is in the 100th place, right? So this is a 8400th. In terms of converting from a decimal number to a fraction, actually it's very intuitive, very easy to do. Basically, you just count how many decimal digits to the right of this decimal point. If you have 2 decimal digits, you're going to have 2 zeros on the bottom. So this is 0.84 equals, you put this decimal part, this whole thing on the top, and 2 zeros on the bottom. You always start with 1, okay? 2 zeros on the bottom, this is 100th, right? And don't forget to simplify it. I see both numbers can be divided by 4, because 8 can be divided by 4, and 4 can be divided by 4. So if I divide by 4, I get 21. 100 divided by 4 is 25. Now, there's no common factor between these two numbers. So this is our final answer. First example. Now, let's look at the second example. We have a negative number. It doesn't matter we have negative number or positive number. The way we convert it remains the same. So basically, this is the way only need to convert the decimal part to the fractional to a fraction, right? So this is negative 217, 1 decimal digit. You will have 1 zero on the bottom, and put this whole decimal part on the top. Apparently, this is a half, right? So we get negative 217 and a half. So that's our second one. Move on to the next page. Now, this is your first exercise set. Let's look at our second learning objective. We are going to write a word name for a decimal number. Basically, just another way to say how to read a decimal number. So the way you read a decimal number is that you look at the decimal part, you read the decimal part as if it were a whole number. And then you finish your reading with the name of the last place value. In case you have a typical decimal number where you have a whole number part and also decimal part, then you first read the whole number part as a whole number. That's apparently, right? And then you read the decimal part as a whole number, and then you finish your reading with the last place value, just like you read the pure decimal part. Now let's look at our first example. Now we only have decimal part. And first we read the decimal part as if it were a whole number. As a whole number, we don't need to read the number zeros in front of it. So this is 489. So let me write 400. Um, 89. Now we finish our reading with the place value of the last digit, last place value. So what is place value of this digit 9? You count from the first decimal digit, which is the 10th. So 10th, 100th, thousandth, 10,000s, 100,000s. After 100,000, we have million. So 10 millions. So this is 10 millions. Don't forget TH. TH is the indicator. It is part of decimal part. So 489 10 millions. That's how many 10 millions you have. 10 millions really means 0.00000001. You have 489 of this. That will give you this value. That's why we read it that way. So read the decimal part as a whole number, then you finish your reading with the last place value. Now let's look at our, this is our second exercise problem. It's the next page. So this is an exercise problem. Now let's look at we should have another example. Oh, we don't have one. Now let me insert another example. It's supposed to be here. So let's say 4039 and 0256. Just a random number. So now we have a typical decimal number. We have a whole number part, we have decimal part. So we read a whole number part as a whole number. This is the 4039. Remember, you don't use AND when you read a whole number. You don't read this one as 4039. The reason is, in the formal way to read a decimal, this decimal point is, we're going to read it as AND. So in whole number, there's no decimal point. You don't read AND. You don't have AND. So this is the 4039 and then we read this decimal part as a whole number, 256. Let's look at the last place value, 10th, 100th, thousandth, 10,000s. So 10 thousandths and with TH. 4039 and 256 10,000s. So that's our reading. This is your exercise. Now let's see how we graph a decimal number on the number line. The first example is 3.6. Apparently 3.6 is between 3 and 4, right? Let's suppose this point on the number line represents 3 and 4. We can divide each unit into 10 subunits, 10 sub-intervals. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is going to be our 4. So apparently 3.6 is between 3 and 4. We are using decimal system. That's why between each unit, we can divide it into 10 smaller units. So we need 0.6. So 3.1, 0.2, 0.3, 0.4, 0.5, 0.6. So this is location of 3.6. So you can just use a dot to represent 3.6. You can also label it. Yeah, it's 3.6. You don't have to label it, but this dot represents 3.6. Now, how about the next one? The next one, we have 3 decimal digits. So I have 3 number lines here. Actually, you only need 1, but I want to show you how I come up with a final answer by doing this step by step. So you just follow my thought process. So apparently, this number is between 14 and 15. Let's suppose this point represents 14. Okay. So this is the 14. We need 10 more units. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is going to be 15. Apparently, this number is somewhere in between, right? Now let's look at second decimal digit. Second decimal is 5. Apparently, this whole thing is bigger than 14.5, right? So it's going to be between 14.5 and 14.6. So suppose this one, when you use, basically it's between here. 1, 2, 3, 4, 5. This is 14.5. And this next one, 14.6, right? And our number is somewhere in between. So let's magnify, basically, magnify this unit into using this second number line. So we start with 14.5. Let's suppose this point is 14.5 here. So now we need another 10 units in between. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this one going to be 14.6. Make sense? So our number is in between 14.5 and 14.6. If you look at that, it's actually this one is between 14.51 and 14.52, right? So this is 14.51. This is 14.51 here. 51. And this is 14.52. It's between these 2 marks, right? Now let's magnify this unit and say, let's say it's using the third number line. Let's call this point 14.51. We need 10 more units. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this one is going to be 14.52. Ours is in between. So ours is 14.517. So 51, 14.51, 52, 53, 54, 55, 56, 57. So eventually this is our graph. 14.517. So actually, when you actually draw this decimal using number line, you only need this one. You just need to start with 14.51. That's 1 digit to the last digit, to 1 digit to the left of last digit. Look at this digit. If this is 1, your answer is between 1 and 2. If your interval is between 1 and 2. If this is 3, your interval is between 14.53 and 14.54. So you just create those, that bracket and locate your actual number in between. So that's how we graph a decimal number on the number line, So we only need this in the end. So let's do another one. This is negative 2.75. The number line is on the next page. So I'm going to rewrite this. We are going to graph negative 2.75. So this second digit to the last one is 7. So it's between negative 2.7 and negative 2.8. For negative numbers, the bigger the number, the smaller the value. So negative 2.8 is smaller than negative 2.7. That's why we start with negative 2.8 on the left, because on the number line, the numbers to the left is smaller than those to the left, to the right. So we need 10 units in between. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this place is negative 2.7. Now this is negative 2.75. It's in between. So this is the negative 2.7, 71, 72, 73, 74, 75. So this are graph. Now here's your exercise. Now our next learning objective, also our example number 4, is that we want to be able to compare between two decimal numbers. When we compare them, basically we line them up according to their place values. So this is the first number, 35.619, second number, 35.625. Now we compare this digit by digit from the left to the right, because in our system, the digit to the left have higher place values. That's why we compare the leftmost digits first. This two the same, so move on to the next column. This two also the same. This two also the same. Now look at this two. This one is bigger. As a result, this whole thing is bigger. So second number is bigger. So how do we write that? 35.619 is smaller than 35.625. Is smaller than. And when we use this inequality symbols, the opening of these symbols always face the bigger number. So that's why we write this way, smaller than 35.625. Now let's look at this next example. We have two negative numbers. Negative numbers are always smaller than positive numbers and 0. But if you have both negative numbers, how do we compare that? So for negative numbers, the bigger the number, the smaller the value. So now we just need to compare the number themselves without negative sign. So line them up, 0.00981, 0.00906. Same. This one is bigger. As a positive number, this is bigger. The size of this number bigger, but since they are negative numbers, the bigger the size, the smaller the value. So like if you have a $10 debt and I have $100 debt, who has more money, relatively speaking? You have more money, because for negative numbers, the bigger the size, the smaller the value. I'm deeper in the debt. You're not that deep in the debt. So that's why we compare the size first. Then if they're negative numbers, the bigger the size, the smaller the value. So 981 is a smaller. This one is smaller. So negative 0.00981 is smaller than negative 0.00986. I made a mistake. 9806. 06. But conclusion is still luckily, right? Still correct. So it is the same. This one is bigger. As a result, this whole thing is bigger, but it's positive number. So a negative number is a smaller. This is still true. Okay, here's your exercise set. Compare these numbers. Now our last learning objective, we want to be able to round a decimal number to a specified place. So we are given this number first, we round it to the 10th place. Now let me write down this number one more time. 28053. First, you need to locate the location of that digit you want to round to. 10th place is the first decimal digit. So we want to round to this digit 2, this place. we always look at the digit to the right, only one digit to the right. We don't need to worry about the rest because this one has higher place value than the rest. So we only need to worry about the digit immediately to the right of the digit you want to round to. Okay. If this digit is 5 or bigger than 5, you round this one up by 1. And this is the case. So we get 917.3. And that's our answer. Now, next one, we want to round the same number to the thousands place. TH is in the decimal part. First, we want to locate this location of thousands, 10, 100, thousands. So digit 0 occupies the thousands place. We look at the one to the right, and which is 5, we round it up by 1. So we get 917.281. So 10, 100, thousands. The last way we want to round it to a whole number. 17.28053. And this is the first digit of whole number. We look at the digit to the right, which is smaller than 5. We simply truncate it. So the result is 917. We don't have any decimal digits because we rounded to the whole number, to a whole number. And that's all for this video. This is the last exercise set. And remember, all of the answers to exercise problems are below the video in the comment area. See you guys in the next video.